Yeah, confirm my audibility. Confirm my audibility. So in this session, we will solve some very good questions which were asked previously in HPCL examination. All these questions are previously asked questions. The questions what we are going to solve are previous questions of HPCL in network analysis. Okay. So हम previous years का HPCL का questions network analysis subject से solve कर रहे हैं. More than 50, more than 50 we are going to solve. More than 50 we are going to solve. Right? Yes, more than 50 we are going to solve, right? Sorry. Yes, first question, the very first question, a series RLC circuit is in resonance when, is asking is in resonance when. What is series RLC circuit resonance? Either series RLC or parallel RLC. Series or parallel RLC. Resonance means series or parallel RLC. Resonance means XL is equal to XC. XL should be exactly equal to XC, right? Now, in series RLC, I can say during resonance, in series RLC, during resonance, current is maximum. Current is maximum. In parallel RLC, current will be minimum. Current will be minimum. Okay. Current will be minimum. That is the difference. See, I'll tell you, questions which were asked in HPCL examination are pretty simple. Simple, very simple questions. One liner questions only, does not involve big calculations. These questions are not going to involve any calculations, right? Let's go to the next question. The inductive reactance of an inductor depends on, you see, don't look at the options. Very simple. XL is equal to omega L. Yes. So XL is equal to omega is 2 pi FL. So inductive reactance is depending on frequency as well. It is depending upon the inductance value. Now read the statements. Read the statements. What is the first statement? First option. Current and inductance. So inductive reactance is nothing to do with, yes, inductive reactance is nothing to do with the current. Inductive reactance is nothing to do with the resistance and it is nothing to do with the capacitance. It is nothing to do with the voltage and resistance. Frequency and inductance. Option is frequency is see, it depends on frequency and inductance, right? Yes or not? Yes. So you see the level of questions. You see the level of questions. Questions are very simple. Questions are very, very simple. Option is 4. Right? Next question. What he is saying? He is saying, which of the following circuit elements can store energy and return to the circuit? See, questions are really silly, I can say. Which elements will store and return back, return to the source? Inductance and capacitance. Inductor stores in the form of magnetic field, capacitor stores in the form of electric field, right? Inductance and capacitor. Resistor can never store. Capacitor, you see here option C, you option 3 you see capacitor only. No, inductor only. Both inductor and capacitor can do that job. That's why it is option 1. That's why it is option 1, right? Next. So this question, little calculation is involved. 2 lines the question is there, but pretty simple question. What is saying? In the following circuit, resistor R1, in the following circuit, resistor R1, R2, R3, all are connected in series. The total current flowing through circuit with 24 volts DC supply. You see 2 ohms, 4 ohms, 6 ohms. This is 246. With the DC, how much? 24. इसने कनेक्ट किया है 24 वोल्ट्स का डीसी. पूछ रहा है करंट कितना होगा. See, we know it very well that in series resistances will be added. In parallel, reciprocal of the resistances will be added. In series, resistance values will be directly added. Now I is equal to, according to Ohm's law, I is equal to V by R. Total resistance is 12. 12 2 it is 2 amperes. It is of 2 amperes, right? Option is 3. See, no question is difficult for HPCL examination. I repeat, no question is difficult for HPCL examination. All are very, 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 very easy questions. Okay, right. Next question. Try it. Yeah, this is also direct theory question. In a RC circuit, the time constant T is given by. See here, one important point we learn. One important point we learn. Series RLC, series RC, or parallel RC. Any RC, it may be series, parallel, or it may be like this. Suppose if it is having like this is the circuit, right? This is the circuit. Okay, so this is certain volts. For example, let's take this is 2 ohms, this is 2 ohms, this is 1 ohm, this is 1 microfarad, this is another microfarad, 1 microfarad, right? Now he's asking this time constant. It is neither series nor parallel, it is some combination of resistances. Series RC or parallel RC or any RC, tau is equal to R equivalent into C equivalent, units are seconds. People will think, sir, for series RC it is RC, for parallel RC it should be 1 by RC. No, it is series RC or parallel RC or any RC. I repeat, it may be any RC. The formula for time constant is R equivalent into C equivalent. Now you see how to find here, sir. For this one, you just separate a resistance part and capacitance part. Now you see this way, voltage source must be short circuited. When you are finding Thevenin's equivalent resistance, voltage source must be short circuited. Now how much is R equivalent you get? R equivalent, if you see from here, 2 in parallel with 2 is 1, 1 plus 1 is 2. Total 2 ohms is R equivalent. Now for capacitance, if you see, now from here you see this way for capacitance. Okay, here let me take, okay, leave it. That's not a matter. If you see this one, as it is open circuit, or let me take one voltage source here also of 5 volts, no problem, right? Now this is short circuited. 1 micro is in parallel with 1 micro. C equivalent will be, capacitance will be directly added if it is in series, right? So option is R into C. R into C. That's all. Option is R into C. Very simple. All the questions are simple questions only, right? Next question. The real power P in an AC circuit is given by, say, S is equal to apparent power in an AC circuit. S is equal to solution. S is equal to P plus JQ. P is called as real power or active power. This is called as real power or active power. Q is called as reactive power. Q is called as what? Reactive power. Now, if I draw its a power triangle, yes, what is power triangle? Yeah, P, J is 90 degrees, P is this, then Q will be this. This is going to be the S. Now let's take this one as theta. Now write cos theta. Cos theta is equal to adjacent side by hypotenuse. So P is equal to S cos theta. Is what? Real power. P is equal to S. What is S? S is equal to V into I conjugate. Conjugate means taking its exactly opposite angle. Conjugate means taking its exactly opposite angle, right? Yes or not? Conjugate means. So magnitude of S means mod V into mod I. Magnitude of S means mod V into mod I. So P is equal to S cos phi. S means mod V into mod I cos theta. Mod V mod I cos theta. Option is 1. Option is 1, right? Next step. In an AC circuit, the power factor is 0.6 lagging. Okay, if the reactive power consumed is same as that of previous question only. With the previous question data, we can solve this question easily. In an AC circuit, the power factor is 0.6 lagging. If the active power consumed is P given, P is 600. Cos theta, what is power factor? Power factor is equal to cos theta is equal to 0.6 lag. Another formula for power factor is equal to resistance by impedance magnitude, or another formula for power factor is P by magnitude of S. P by magnitude of S, right? If the active power consumed is 600 watts, then what is the apparent power? See, P is equal to S cos phi, just S cos theta. Just now we learned P is 600. S we want, cos theta is 0.6. So S is equal to 600 divided by 0.6. How much it is? 1000 volt amperes. It is 1000 volt amperes. Option 1 is perfectly correct. Option 1 is perfectly correct. Right? Next. A capacitor C is equal to 20 microfarads in an RL circuit has a voltage across it given by V of t is equal to 100 sin 2000 t volts. What is the instantaneous current through the capacitor at t is equal to 0? Yes. See, he is asking this is the voltage source, this is the voltage source, this is the capacitance, this is xc, xc is equal to 1 by omega c, this is V of t. Now he is asking about current, he is asking about current. Yeah, this is in ohms. So I of t is equal to voltage divided by xc, that is voltage by 1 by omega c will be into omega c. So I of t is equal to, what is V of t? V of t is 100 sine 2000 t into omega is how much? Here this is omega 2000 into yes, but current leads, it is going to be see, I can write minus j xc, minus j xc, I forgot actually minus j, so this will be plus j, this will be plus j, so plus j means sine 2000 t plus 90 degrees. Okay, omega c, how much is c? C is 20 microfarads, 20 into 10 to the power of minus 6. Now this will be cos 100 cos 2000 t, 100 cos 2000 t into, see, 2 into, this is 10 to the power of 4, 4 into 10 to the power of 4 means 10 to the power of minus 2, 4 into 10 to the power of minus 2. At t is equal to 0, this cos will be 1, cos 0 will be 1. 100 into 4 into 10 to the power of minus 2. So 10 to the power of minus 2 plus 2 gone. The answer is 4. Answer is 4 amperes. Very clearly, simple, simple. You see how simply we got it. But if you forget that j to take, how I forgot to take, if you forget that j to take, then it will be difficult. It will be difficult. Okay, you'll get wrong answer. You'll get wrong answer. Right? Yes or not? How simple it is, right? Let's go to the next question. If you have any question in your mind, you can type in the chat box. I'm able to see the chat box, right? Any question, any kind of question you have, you can ask. ये क्या बोल रहा है यहाँ पे? What he is asking? An inductor of L is equal to 2 Henry is connected to a DC voltage source of 10 volts at T is equal to 0. ठीक है? Okay. What is the rate of change of current through the inductor? Rate of change of current. Rate of change of current is nothing but di of t by dt. He is asking about what? Di of t by dt. Now, take a DC voltage source. Take a DC voltage source. This is plus minus V. What? To inductor it is connected, to inductor it is connected, right? Then current that is flowing is I of t, write the KVL, minus V plus L di of t by dt is equal to 0. So from this one, L di of t by dt is equal to V. So from this one, di of t by dt is equal to V by L. V by L, right? How much is voltage? 10. How much is L? L is 2. So how much it is? 5 amperes per second, di by dt, amperes. 5 amperes per second. Option is DD for Delhi. You see how simply we got. Option is D for Delhi, right? Next. In an RL circuit, the inductor current has 0 initial current. Okay. When the switch is open, what does the inductor behaves like just after the switch is closed? See, 4 statements I'm giving. See, initially means t is equal to 0 plus. Finally means t is equal to infinity. Now we have 2 elements here. One is inductor, another one is capacitor. This is inductor. This is inductor. Initially, inductor behaves as open circuit. Finally, inductor behaves as short circuit. Capacitor initially Initially, capacitor behaves as a short circuit. Finally, it behaves as open circuit, right? So he's asking at t is equal to 0 plus the inductor behaves as an open circuit. Open circuit. Please remember this table. A small table I provided there. A small table I provided there. Please use that table. Please use that table. Right. Next. In an RL circuit, the inductor has zero initial current. Okay. When the switch is open, what does the inductor? Yeah, this is a repeated question. Previous question only repeated. A series RLC circuit has series RLC. R is equal to 10, L is equal to 200, C is equal to 50 microfarads. What is the impedance at resonance? At resonance, see, first of all, for series RLC, how series RLC looks, this is series RLC. This is going to be series RLC. This is in ohms. This will be plus JXL in ohms. This is minus JXC in ohms. Now, the total is impedance Z. Z is equal to R plus JXL minus JXC. Z is equal to R plus, if I take J common, XL minus XC. Yes, sir. At resonance, he's asking at resonance. At resonance, XL is equal to XC. Therefore, Z is simply equal to resistance. Even in parallel RLC also, see this is this Z is equal to R. Even in this is correct for both. See, I can write. See R. This is L. This is C. Right. Now this is JXL. This is minus JXC. This is R. So during resonance, XL is equal to XC, then parallel combination is XL into XC by XL minus XC. This will become infinite. This will become infinite. That will become what? Infinite. Infinite in parallel with R is what? R only. Infinite in parallel with R is what? R. For both series and parallel RLC. For both series and parallel RLC. Right? Option is Z is equal to R. How much is R? R is 10 ohms. R is what? 10 ohms. Option is A. Next. What is the shape of the response curve for a series resonance circuit at a resonance? What is the shape of the response curve? As I told you, at a series resonance, at resonance, this is the frequency, this is 0. Somewhere this is the resonant frequency. Below resonance, see, below resonant frequency, current is this way. For at resonance frequency, current is max. And after resonant frequency, the current decreases this way. This is I of t in the circuit. I of t in the circuit, right? So current is maximum at resonance. Current is maximum at the resonance, right? This is the response curve. Now, see, this is I of t curve. Sir, what about impedance? Impedance is maximum before resonance and after resonance also. At resonance, it is going to be minimum. This is Z curve, impedance curve, right? Current is maximum. Yes or not? Next, in a series RC circuit, answer this question. Try to answer, ma. Try to answer. Yes, if you have, see, try to answer, please. 1 minute is the time I'm giving. If you are not in a position to solve, I'll solve. I'm expecting answer from you. Please type in the chat box. Yes. Yeah, what is saying? In a series circuit connected to an AC supply, okay, series circuit connected to an AC supply, yes, plus minus, okay, RC circuit is, this is R. In AC, capacitance can be represented as minus JXC. What is this? This is V of t. Now what is asking? So from here, if you see, This is called as impedance Z. Z is equal to R minus J XC. R minus J XC. Then phase angle phi. Phase angle phi is equal to what? Phase angle phi between voltage and current. First of all, let's find current. Let's find current. Okay. Yeah, current is I of t. Now, I of t is equal to V of t by Z R minus J XC. So I of t is equal to, what is V of t? It can be written as V at an angle 0 by mod Z at an angle of minus tan inverse of XC by R. Minus tan inverse of XC by R, 1 by omega RC. XC is equal to 1 by omega C, right? X is equal to 1 by omega C minus J by omega C, right? Now, this angle when it goes to upside, V by mod Z at an angle of plus tan inverse of 1 by omega RC. Option is C, C for Chennai. Tan inverse of 1 by omega RC, right? Tan inverse of 1 by omega RC, right? Now, in an RC circuit, a capacitor has, see, none of you responding, I don't know why. I asked you to type answer in the chat box, but none of you responding. Please respond. Simple questions only. This will be a good practice for you. In an RC circuit, a capacitor has zero initial voltage with the switch open. Just after the switch is closed at t is equal to 0, how does the capacitor will behave? I given initially, you can come back at t is equal to 0, capacitor behaves as, yes, at a t is equal to 0, here I given a table, at a t is equal to 0, capacitor behaves as short circuit. Capacitor is going to behave as what? Short circuit. At t is equal to 0, capacitor behaves as simply a short circuit. Option is A, right? I given a table, right? Next. In a basic series inverter circuit, what is the expression for damping factor? So he's asking about inverter circuit, okay? But basic series RLC circuit will take. There is no separate inverter circuit. Inverter comes under power electronics, okay? Now series RLC, if you take R in S domain, L will be NS, LS, capacitance will be 1 by CS. If I find its current to voltage ratio, this is VI, this is current I of S by V of S. Now I am finding current. Current is equal to voltage, Ohm's law, divided by R plus LS plus 1 by CS. Yes, R plus LS plus 1 by CS. You may be thinking, sir, why you are taking current into consideration? Why not voltage across resistor or voltage across inductor or voltage across capacitor? Why you are taking current into consideration? The reason is, see, you can take any variable as your consideration. You can take any possible variable as the consideration. There is no problem. You can take voltage across resistor. You can take voltage across inductor. You can take voltage across current in the circuit. Whatever you want to take, you can take. There is no restriction about that. There is no restriction. Now, current I of S is equal to VI of S by R plus LS plus 1 by S. Now, what is transfer function? Laplace transform of output by input. Send this side. What you get is R plus LS plus 1 by CS. Now CS will go upside, LCS square plus SCR plus 1. Now CS by, take LC common, S square plus R by L into S plus 1 by LC. Now this CC gone, send that L to the upside, S square plus R by L into S plus 1 by LC. Now compare that one with the standard equation, S square plus 2 zeta omega n S plus omega n square. Compare this denominator, which is called as characteristic equation, with the standard equation. Now omega n square is equal to 1 by LC. From this one we got omega n equal to 1 by under root of LC. 2 zeta omega n is equal to R by L. If you solve this, you get zeta is equal to R by 2 into root of C by L. I'll write in the next page. Because I wanted to write for parallel RLC also. I'll tell you how to remember for parallel RLC. Zeta for series RLC. Zeta for series RLC is equal to R by 2 into under root of C by L. For parallel RLC, it is very simple. Zeta for parallel RLC, 1 by 2 will be as it is, 1 by 2 will be as it is from there to here. R will become 1 by R. C will become L, L will become C. That's all. Duality. The concept of duality I applied. The dual of capacitance is inductance. The dual of inductance is capacitance. Right? The dual of resistance is conductance. That is 1 by resistance. Yes. So yes or not? Yes. That is what we are learning. Sir, ये क्लास केवल लाइव होती है क्या? See, recorded I don't think you will get. See, anyhow that is there in on YouTube. No, sorry, अंकित, YouTube में मिल जाएगा आपको. YouTube में हमेशा के लिए रहेगा ये क्लास. ठीक है, ये कहीं नहीं जाएगा. Okay, next question. Next question. An inductor of L is equal to 0.5 Henry carries a current given by I of t is equal to 40 amperes for t greater than or equal to 0. What is the voltage across the inductor at t is equal to 2 seconds? Voltage across inductor VL of t is equal to L dIL of t by dt. Straight formula, we know that. So VL of t is equal to L. How much is inductance? 0.5 d by dt of 4t, that is equal to 0.5 into 4, that is equal to 2 volts. Answer is what? 2 volts. That is option A. Answer is 2 volts. That is option A. Right? Simple. Pretty simple. Yes or not? Next. A series RLC circuit. See, this is a very simple question, direct formula based. A series RLC circuit has a resonant frequency of 1 megahertz, has a resonant frequency of 1 megahertz and bandwidth of 10 kilohertz, right? What are the lower and upper cutoff frequencies? See, lower cutoff frequency F1 is equal to bandwidth minus, I can say, resonant frequency. Yes, bandwidth, resonant frequency. See, resonant frequency by 2. Upper cutoff frequency F2 is equal to bandwidth plus resonant frequency minus 1 by 2. This is 9.5. 9.5. Yes. See, then, okay. What is saying is series RLC circuit has a resonant frequency of 1. Okay. Yes. What will be the upper and lower cutoff frequencies? See, here it is 1. Here it is 1. Okay. Here it is 1 minus 0.5. Yes. No, somewhere we missed. Just a minute. Somewhere we missed. Simple question, direct formula. Yes, just a minute. See, 1. What is the resonant frequency? Resonant frequency is 1 megahertz, right? And a bandwidth of 10 kilohertz. Okay. Upper and lower cutoff frequencies. See, 1 minus, it is going to be 0.05. 1 minus 0.5, you get 0.9, no, 1 minus 0.5 it is. 1 minus 0.5. Yes. I think this is a 0, not 0.05, sorry. 0.95. 0.95. Another is 1 plus 0.05, that is equal to 1.05 you get. Okay. So option is a D. Option is D. Okay. See, upper cutoff, this is lower cutoff frequency. Lower cutoff frequency is this. Upper cutoff frequency is this. This is lower cutoff frequency. This is upper cutoff frequency. Sir, why you subtracted 0.05? This is in kilohertz. If you convert into megahertz, right? 10 kilohertz, right? 10 into 10 cube, 10 to the power of 4 means if I convert into mega, what I should write? I need to write one more 10 cube. I have to multiply, then divided by. See, 10 to the power of 3 I multiply, 10 to the power of 3 I divide, then 10 mega by 10 cube, 10 mega by 10 mega hertz by 10 cube means what? 1/10 gone. So this is going to be 0.01 megahertz. 0.01 megahertz, right? 0.01 megahertz you get. Now for that 0.01 megahertz, see, I write here lower cutoff frequency is equal to, so this is bandwidth, resonant frequency minus bandwidth by 2. Upper cutoff frequency is equal, sorry, upper cutoff frequency is equal to resonant frequency plus bandwidth by 2. Previously I wrote wrong, bandwidth minus fr by 2 I wrote that is wrong, fr minus bandwidth by 2. Now what is resonant frequency? 1 mega minus bandwidth is 0.01 divided by 2. This is 1 plus 0.01 divided by 2. How much is 0.01 divided by 2? 1 minus 0.005. Now this will be 0.995. So this will be 1 plus 0.005. This will be 1.005. 0.995, 1.005. Option is D. This is not correct. This is not correct. I wrote, I taken it as 0.05. It is going to be 0.005. 0.005. Right? Option is D. Please try it. I'm giving you 1 minute of time. You can type your answer in the chat box. Yes, all of you type, please. Yes. What is the question? क्वेश्चन में क्या पूछ रहा है उसने? A series RLC circuit has inductance 4 Henry, resistance 8 Henry, and resonant frequency 50 radians per second. What is the quality factor? What is quality factor? See, quality factor will tell us about the energy storage by energy dissipation. Energy storage by energy dissipation. The quality factor for RL circuit is quality factor QF is equal to omega naught L by R. Omega naught is the resonant frequency. Omega naught is resonant frequency, which he given as omega R 50 into L is 4 divided by R is 8. Yes, 4 2s, it is 25. Quality factor is not having any units. What is quality factor? Basic formula. Quality factor is equal to energy stored, maximum energy stored per cycle divided by maximum energy dissipated. If we use that concept and if we do, we get for, see, this is for RL circuit. Sir, what is the formula for RC? Quality factor is equal to 1 by omega RC for omega naught into RC for RC network. Right? Next question. Try this. Yeah. A series RLC circuit has a resonant frequency of 20 kilohertz, FR is given, and quality factor is given. What is the bandwidth of the circuit? Is asking about the bandwidth. Try for 1 minute, please. Try for 1 minute. Yes. 1 minute is the time I'm giving. You can try. Simple question. You can use the previous formulas. Right? So one must know what is the bandwidth formula of RL circuit. One must know what is the bandwidth formula of RL circuit. Right? So a series RLC circuit has a resonant frequency, FR, that fellow given. FR is equal to 20 kilohertz. That's fine. Quality factor Q he given 100. Then what is the bandwidth? Bandwidth of series RL circuit is equal to L by R. Bandwidth is L by R. Right? Now Q, what is Q? Omega naught into L by R. He is asking 100 is equal to omega naught. What is omega naught? 2 pi F naught or FR. 2 pi into 20 into L by R is nothing but bandwidth. Now bandwidth is equal to 100 divided by 2 pi into 20. 100 divided by 2 pi into 20. That's all. Yes, 100 divided by 2 pi into 20. If you solve it, you get that. Yes, if you solve it, you get. Yes or not? Yes. Actual bandwidth is R by L, please. R by L, sorry. R by L, not L by R. Now, this is 1 by bandwidth. Now, what is bandwidth? So, bandwidth is equal to 2 pi into 20 kilohertz into 10 cube divided by 100. 0, 0 gone, 0, 2 times gone. So, bandwidth is equal to 4 pi into 100. 4 pi into 100. But in options, it is not there. Yes, the relationship between bandwidth and quality factor. See, first of all, series RLC, he is saying. He is not saying series RL, please. He is not saying series RL. Series RLC he is saying, right? Now, what was the bandwidth formula of series RLC circuit? Yes, series RLC circuit bandwidth formula, that is equal to, means a series RLC circuit bandwidth formula is either you can take omega naught into L by R, or you can take 1 by omega naught into RC, 1 by omega naught into RC, right? Yes, bandwidth, same it is, sorry, not bandwidth, quality factor. Quality factor of series RLC circuit can be taken as omega naught into L by R you can take, or you can take 1 by omega naught into RC. 1 by omega naught into RC. Bandwidth is either RL or 1 by RC. Either RL or 1 by RC. Either of those two. Either of those two. Right? But the options is not matching. Maybe question options are not properly given. Options are not properly given. Right? Yes. Let's move to the next question. Yeah. What he's saying in this question? What he's saying? A single phase AC circuit has a voltage of 230 volts. Okay. Voltage is 230 volts and current of 10 amperes with a power factor of 0.8 lagging. What is the real power? P is equal to, see, direct question, P is equal to VI. Let me write the formula. P is equal to VI cos phi. VI cos phi. P is equal to, how much is V? Voltage is 230. I is 10. Cos phi is how much? 0.8. So P is equal to 230 into 8. Yes, 1600 plus 2400. Sorry, 240. 1600 plus 240. How much it is? 1840 watts. 1840 watts. Option is C. C for Chennai. Simple question. Simple question. Right? See, any question you have, you can ask. Sir, are these questions for junior executive, for officer? ये सी, ये सारे के सारे क्वेश्चंस है ऑफिसर पेपर में से हैं. ठीक है, ऑफिसर पेपर बहुत सिंपल क्वेश्चंस है. जो मैंने क्वेश्चंस लिया है 50 प्लस क्वेश्चंस since last 5 years, 5 papers, not 5 years, 22, 23, 24, 25, 2 papers. One is HRRL, another is HPCL. So all these 5 papers questions I taken, right? Network analysis question. Next question. Yes. A series RL circuit with R is equal to 5 ohms and L is equal to 2 Henry and 10 volts DC source is in steady state. Okay. RL circuit is in steady state. You know that inductance at steady state means final resistance. Inductance will be a short circuit under steady state. What is the source? What is the source here? 10 volts DC. 10 volts DC. So this is 5 ohms. The final current means not final. The steady state current is 2 amperes. Okay. The switch is moved to connect only to the inductor and resistor 10 ohm. What is the I of 0 plus just after switching? Now what he is saying, here there was a switch, here there was a switch. Now he is disconnecting the source. He is disconnecting the source, yes, and he is making to close the switch. This is 5 ohms. This is whatever maybe L is 2 Henry. Now this current will remain same. Current will remain same. Why? Because inductor does not allow sudden change in its current. Current will remain same. Why? Because inductor does not allow sudden change in its current. How much is the current previously? 2 amperes. Even now also it is 2 amperes. Inductor does not allow sudden change in its current. Misunderstand nahi karna. Inductor see, inductor, if you observe carefully, will not allow sudden change in its current. Don't misunderstand, like inductor is not going to allow the current. Inductor will allow gradual changes, not sudden changes. Inductor will allow gradual changes in current, not sudden changes. Option is B for Bombay. Has L is equal to 50 millihenries equal to 20 microfarads and R is equal to 10 ohm. What is the quality factor at resonance? Just now I told you quality factor is equal to for RL omega naught L by R, for RC for RLC, for series RLC, either you can take omega naught L by R or you can take 1 by omega naught RC at resonance. Quality factor we have to find at resonance only. Now, yeah, R by L is bandwidth. Okay, 1 by RC is bandwidth. Previous question we did not get the answer. That's why I'm giving you the confirmation. There is something wrong in the options. Now, quality factor is asking omega naught. What is omega naught resonant frequency? What is that? 1 by under root of LC. 1 by under root LC. 1 by under root of LC into L by R. So L root L times it is gone. 1 by R into under root of L by C. How much is resistance? 10. L is how much? 50 milli. 50 into 10 to the power of minus 3 divided by C is how much? 20 micro. 20 into 10 to the power of minus 6. Right? So 1 by 10 into under root of into 10 to the power of minus 3. Solve it, you get. But quality factor, yes, series RLC circuit, that value. Yes. Yes. Answer, please. I'm waiting for your answer. Answer, please. Either you can do this way also. Either you can do this way also. If this calculation is becoming big, you can do this way also, right? Next question. Is asking for the transfer function. Is asking for the transfer function. What is transfer function? Laplace transform of output by Laplace transform of input. Yes, sir. This is 4 ohms. This is LS. 6S. 6S. This is 2 ohms. This is 1 by CS. 1 by C is 5. 1 by 5S. Okay. This is V0. This is V0 of S. This is VA of S. This is VA of S. Now apply voltage division. V0 of S is equal to what? VA of S into output impedance 2 plus 1 by 5S by 4 plus 6S plus 2 plus 1 by 5S. If we simplify it, we get the answer. If we simplify, we get the answer. What is the numerator? 10S plus 1 by 5S by, yes, 20S plus 30S square plus 10S plus 1 by 5S. 5S gone. So 10S plus 1 by 30S square plus 30S plus 1. Yes. Yes or not? Yeah. So 10S plus 1. 10S plus 1. Option either 1 or last one. Either 1 or last one. But if you see, here S is there, but it should be 30S. So option is D. Option is D. Simplification. You can take care of the simplification. You can take care of the simplification, right? Yes. Yes or not? Next question, please. Study the given figure and find the output voltage V naught. He's asking about output voltage V naught. Okay, I think a figure is not clearly visible. Figure is not clearly visible. Just a minute. Now it is clearly visible, right? Now it is clearly visible. Okay. Now he's asking the output voltage V naught. Very simple. In time domain, we can't solve this one. In time domain, we can't solve this one. Apply S domain. What is this? 4 by S plus 1. Now this is this only. This is 1 by CS. 1 by C is 20 into 10 to the power of minus 6 into S. So 10 to the power of 6 by 20 S. Right? Right. So 10 to the power of 5 by 2S. Right? Ohms. Now apply current division. Apply current division and give me. Just apply current division and you can give me the option. Right? Yes or not? Yes. Apply current division. How to apply current division, sir? Yes, normally only na. 4 by S plus 1 total current into, we want current in this one. So voltage of this one we want. Voltage of this one we want. First of all, I want this current IC of S. I want current through the capacitor IC of S. Total current is 4 by S plus 1 into opposite impedance 10K by total impedance. How much is the total impedance? 10K plus 10K plus this is a 10 to the power of 5 by 2S, right? Into this impedance. Now I want a voltage across capacitor VC of S, that is equal to 4 by S plus 1 into 10K by 10K plus 10 to the power of 5 by 2S into how much it is? 10 to the power of 5 by 2S. Apply inverse Laplace transform, we get VC of t. See, why I am not solving this completely is, the reason is why I am not solving here is, control systems is not there in the syllabus. Okay, this is a question from S domain part. S domain part. Okay, if you are good at Laplace and inverse Laplace transforms, that's it. That's it. Yes, you can simplify it. Yes, you can simplify it. You can get VC of t. The method I given you, convert into S domain 4 by S plus 1. This is 1 by CS, 1 by CS, right? Now apply current division, you get the current of this one. Then you have current and its impedance 10 to the power of 5 by 2S. Then you get the voltage in S domain. Convert into time domain, you will get that one, right? Yes. What will be the transfer function of the network? Yes, this is also not clearly visible. Let me increase the size. Let me increase the size of the question. What is asking question? What will be the, just a minute, became too big. So he's saying what is the transfer function of the figure given below. Now this VC of t will become in S domain VC of S. VA of t will become VA of S. C will become 1 by CS. Now VC of S, output voltage, or V naught of S. V naught of S is equal to input voltage into output impedance by total 1 plus R plus 1 by CS. So V naught of S by VI of S is equal to what you get? 1 by simply SSCR plus 1 you get. 1 by SCR plus 1. But that fellow, this is not even a question at all. That this is not even a question. What is asking? Observe clearly here. V naught of S by VI of S. Transfer function definition is asking. See, now control systems is not there in the syllabus. Control systems is not there in the syllabus, right? That's why the questions from this area you may not get in your exam, upcoming HPCL examination, right? Yeah. Next question. Study the given circuit. Find the equivalent inductance between A and B. Is asking to find the equivalent inductance between A and B. Right? Now observe. I'm going to draw. Let me take this point as C. C this point as D. Right? A B C D. A B C. Point A. Okay. He is asking between A and B, right? Yeah. Let me take this one as B. This one as C. This one as D. Between A to C, yes, we have 10 Henry. A to C, we have 10 Henry. C to D we have 27 Henry. This is how much? 27 Henry, right? A to D also we have. A to D also we have. How much A to D we have? A to D we have 15 Henry. 15 Henry. Just a minute, please. Allow me a moment, please. Allow me a moment. Yes. Next is B to C. B to C we have 16 Henry. B to C we have 16 Henry, right? B to C we have 16 Henry. Next, C B to D, B to D we have 24 Henry. This is 24 Henry. If you see, this is a bridge circuit. This is a bridge circuit. This is A and B. This is A, this is B. Now we have to check for the bridge balance. If bridge is balanced, this middle one can be neglected. Now how to check the bridge balance? 16 into 15. 16 into 15 is equal to opposite elements product is equal, then bridge is said to be balanced. 10 into 24. 24 into 10. How much is 16 into 15? Calculate and tell me how much is 16 into 15. Right? 16 into 15. 16 into 15. How much it is? 240 it is. So this side 240. 240 is equal to 240 means the bridge is balanced. If bridge is balanced, we can neglect this one. Once we neglect that, let me draw here again. Once we neglect that, we get this is 10 Henry, this is 16 Henry. 10, 16, right? This is 15, this is 24. This is 15, this is 24. How much this is? 26 in parallel with 39. 26 in parallel with 39. Yes, sir. What is that? 26 into 39 divided by 26 plus 39. So I can say 40 plus 25, 65. Denominator is 65. 26 into 39 divided by 65 is the answer. 65 is the answer, right? Answer it, please. 26 into 39. 26 into 39 divided by 65. It is exactly 15.6. 15.6. Option is 3. In another way also, see, option is 3. Right? Simple question. Bridge balance you have to check. How to check the bridge balance? Product of opposite elements we have to check. If the product of opposite elements is equal, then it is balanced. Otherwise, it is not. An RC series circuit has a resistance of 100 ohms and a capacitive reactance of 100 ohms. Okay, resistance is 100, capacitive reactance is 100. Resistance is 100, capacitive reactance, sorry, it is not inductive reactance, capacitive reactance. Capacitive reactance is also 100. This is 100, this is minus J 100. The phase difference between the voltage and the current, phi angle, phase angle phi is equal to tan inverse of, yes, tan inverse of, I can say, imaginary part by real part. Yeah, Z is equal to R minus J XC. So it is 1. Tan of 1 is how much? 45 degrees. Exactly, you get 45 degrees. And one more thing, in a capacitive circuit, current leads the voltage. In a capacitive circuit, current leads the voltage. Yes. Yes or not? Yes. Next. Calculate the transfer function for the given circuit. He's asking for the transfer function. Again, this capacitance will be 1 by Cs, 1 by 2s. No, two capacitance are there. Now, both the capacitance in parallel can be added. This will be 6 total. 4 plus 2. Capacitance in parallel will be added. 4 plus 2 is 6. 1 by Cs, 1 by 6s it is. This is 1 by 2s. Right? This is V0 of s. This is Va of s. So V naught of S is equal to Vi of S into 1 by 6S by total 5 plus 1 by 2S plus 1 by 6S. So V naught by Vi is equal to 1 by 6S by this is let's simplify this. 5 plus how much this is 6S, this is 2 3S, uh, this is 3, not S. By S will come. This is 3, this is 1 now. Right? Now 1 by 6S by 30S plus 4 divided by 6S. So 6x gone. I think 6s gone. That is equal to 1 by 30S plus 4. 1 by 30S plus 4. Yeah, somewhere calculation is gone. But uh, I don't think. Let's take 30 common in the denominator. If you take 30 common in the denominator, 1 by, if I take 30 common, S plus 4 by 30. So 1 by 30 is 0 0.03. 0 0.03 divided by S plus 4 by 30. How much it is? 0 0.12. 0 0.03 by S plus 0 0.12. Option is 2. Option 2. Right? Yes or not? Yes. Next question. Again, is asking us to find the transfer function. So this is ls. These two can be added. This is 4. This is 3s. Now V naught of s is equal to Vi of s into output impedance 4 divided by 4 plus 4 plus 3s. This is pretty simple. So V naught by Vi is equal to 4 by 8 plus 3s. Now this fellow taken 3 common, then 4 by 3 by s plus 8 by 3. 4 by 3 by s plus 8 by 3. Right? Option is 3. Option is 3. Right? Next question. So is asking for the ammeter current reading. This is very simple question. Try it. Try for 1 minute. Yes. Try for 1 minute. Then I will solve. Yes. I'm giving you 1 minute of time. Please try it, all of you. All of you try it. Yeah. So very simple. Ammeter is ammeter only. 0.2 in parallel with 0.2 is how much? 0.1. 0.1 plus 2 is how much? 2.1. 2.1 in series with the 0.1, how much? 2.1 plus 0.1 is 2.2. Total resistance is 2.2. Then I is equal to, that current small I is equal to voltage divided by total resistance. This is 1 by 2, that is equal to 0.5 amperes. That is 0.5 amperes will come here. This ammeter is going to read 0.5 amperes as the reading. Ammeter is going to read how much? 0.5 amperes. Option is what? 0.5 amperes. Simple, pretty simple question. Right. Now question is looking small. Let me increase the size. Okay. Yeah. What is saying? A balanced star connected source with VAN is equal to 200 at an angle of 10 volts is connected to a delta connected balanced load of 16 plus J8 ohms per phase. Calculate IAB and IC. IAB and IC. See, I will tell you, let us not calculate. Let us do it with our intelligence. Without calculation, one is line current. IAB is line current. IC is phase current. We know that line current leads the phase current by 30 degrees. Means the phase angle difference between IAB and IA should be 30 degrees. 30 degrees. Means IAB should have 30 degrees extra compared to IA. Now, IA, IB, IC. So, if IA angle, or we have to calculate only. We have to calculate. Yes, okay, we'll do that. Okay, how much is what is the current? See, let me take up a next page, a new page. Yeah, he's saying delta connected. Yes, which one is delta connected? Yes, a balanced star connected source is star connected and load is delta connected. Load is delta connected with what value? Load is delta connected with what value? 16 plus J8. Yeah, 16 plus J8, I'm converting into star. I'm converting that into star. Okay, then what will happen? Yeah, in star impedance will become by 3 by 3. So this is the impedance, this is the impedance, this is the impedance, right? Now source is also star. Now load is delta, but we converted that into star, right? Now as it is balanced, neutrals are hypothetically connected. 16 plus J8 by 3, this is a 200. Now this current is IA is equal to, right? IA is equal to, is asking what? IAB and IC. Okay, IA is equal to 200 at an angle of 0 divided by 16 plus J8 by 3. So that is 600 by under root of, I want magnitude, root of 16 square plus 64. 8 square is 64. Now tell me, IA magnitude we are calculating, IA magnitude. The magnitude of IA, IB and IC must be equal. The magnitude of IA and IB, IC must be equal, right? The magnitude of IA, IB, IC must be equal. 16 square, how much it is? Under root of 320. Root of 320. Root of 320. I'm calculating. 17.78, 17.88. 17.88 it is. Now 200 divided by 17.88 will be 11.18. So 11.18 is the magnitude of the current. At least the magnitude if we got, nowhere 11 is there. What happened, man? See, voltage is 200 at an angle of 10. Okay, delta connected to a delta connected balanced load of 16 plus J8. I convert it into star. If I convert into star, 16 plus J8 by 3, right? 200 at an angle of 10 degree. Yes, at an angle of 10 degree uh, by 16 plus J8. So how much it is? 1600 divided by root of 16 square plus 64 at an angle of 10 minus angle, if you want, minus tan inverse of, why minus? Downside angle is coming to upside, imaginary by real, right? So this should be the magnitude. Magnitude of IA must be equal to magnitude of IB, must be equal to magnitude of IC, right? So it is 600, sorry, I taken wrong. Yes, it is 600. I taken it as 200 divided by 600 divided by 17.88. 600 divided by 17.88. Yes, it is 33.55. Yes, 33.55 amperes is IA, whose magnitude is equal to IB, whose magnitude is equal to IC. But you know, all options are having same current, IA, right? Okay, we got IA. IA, how much we got? IA, how much we got? Okay, 33.53 at an angle of, sir, we want angle. This angle is 10. This is tan inverse of 8 by 16. Tan inverse of 8 by 16 means tan inverse of 2. 8 by 16 means what? Tan inverse of 2. Let us do tan inverse of 2, but without calculator. Let's do without calculator only. This question is intended for without calculator. This question is intended for without calculator. Now, let's not use calculator now. Let's not use any calculator. Why? Because in your exam calculator is not allowed, right? But it is demanding for calculator. We use our intelligence to calculate that value without calculator. Now tell me, see, IAB he want and IC he want. IAB is a line current, okay, line current. Now IC is phase current. Now IA, IB, IC. Now IAB, IBC, ICA, right? Now this line current leads this one by 30 degrees. IAB leads IA by 30 degrees. IBC leads IB by 30 degrees. ICA leads IC by 30 degrees, right? Imagine if I'm taking IAB as IAB angle as 0, I'm taking for reference. Then how much is IBC angle? Angle of IBC will be minus 120. Why? Why? As it is balanced, the phase angle difference between one current to another current must be 120 degrees. right? Now angle of ICA will be minus 240 degrees, minus 240 degrees, right? Now then IA angle is what? IA angle is a minus 30. Why? IAB angle leads IA by 30 degrees. What is the angle of IB then? IB angle is minus 150. What is the angle of IC? IC angle is minus 270. Now he is asking between IAB and IC. This is IAB and IC is so this angle difference between these two currents will be 270 degrees. It should be there. 270 it should be. 270 degrees it should be, but you see 133 minus of minus, it is 270 plus 270 or minus 90, both are same. We can check angle difference either should be 90 or 270, plus 270 or minus 90. Here it is not angle difference of this one and this one, neither it is 90 nor it is 270, leave it. But here we are getting it as 106. Yes, it is 10. It is 90. Yes, this angle is 90. This angle is 90. This angle is 90. We are getting it. This angle is 90 degrees. Now, this angle difference is also 90 degrees. This angle difference is also 90 degrees. But leading lagging, you see, IC is in lagging, means IC 90 degrees lags by IAB, means IAB should lead. IAB should lead. Now in this case 90 degrees it is, IAB is lagging, it is having more negative. This is not correct. Here IC is leading, this is also not correct. Option is, sorry, no, which one is leading? He is asking IAB and IC. IAB and IC. Fine. Here if you see current, IC should be lagging compared to IAB. Yes, IC should be lagging, IC should be lagging compared to IAB. And one more thing here, I think this is the line current, this is the phase current. The reason is, if you see phase current is if this is phase current is more compared to line current, which is not correct. We know one thing, that I line is equal to root 3 times of I phase, right? That fellow given options in jumbled way, means actually IAB and IC he given. You don't consider this one as IAB. This one is IAB. Yes, option C correct. This is IAB. The reason is magnitude of line current should be more than phase current. Line current should be more than phase current, right? And we calculated, in fact, we calculated IC. How much we got IC? How much we got IC? Yes, sir. 33.55. Then how come phase current, line current is less? Something is missed in this. See, line current is always root 3 times of phase current in a balanced network, delta connected system, right? Wrong, that is wrong. Leave it. Leave it. Okay. Options. But I clearly explained you how to solve. How to solve? Observe the angle difference. Why? Because calculator is not allowed. It will take a lot of time for you to solve that particular question. Then what to do? Use, instead of using calculator, yes. Yes or not? Study the given circuit, calculate the power dissipated by 4 ohms resistance. See, both are DC. So this will act like short circuit. Yeah, DC only. Why? DC only. Frequency is not mentioned. It is DC only. Angle is 0, right? Observe here. This is how much? 24 volts. How much is this? 2 ohms, right? How much is this? 10 volts. Right? DC. Why? Because frequency is not mentioned by him. This is 4 ohms. For DC, at steady state, inductor behaves as short circuit, right? Now, he's asking what is the power dissipated by this? Power dissipated this. Let's find the current in that. Let's find the current in that. How to find? Very simple. This is this voltage is 10. 10 divided by 4 is 2.5 amperes. So power dissipated by 4 ohms is equal to I square 2.5 whole square into 4. How much is 5 by 2 whole square? 25 by 4 into 4, this is simply 25 watts. This is how much? Simply 25 watts. Yes or not? That is simply 25 watts. Clear? Let's do the next question, please. Let's do the next question. Do it, all of you. 1 minute time I'm giving. 1 minute time I'm giving. Right? Yes or not? Yes, 1 minute is the time I'm giving. He's asking, study the given circuit, convert the delta network into equivalent star network. He's asking us to convert from delta to star to delta to star and star to delta. Let's understand delta to star and star to delta, right? Now convert this delta to star. Convert this delta to star. Any delta to star delta. How much is this? How much is this? I'll tell you. We have the values 30, 40, and 40. 30, 40, and 40. Yes, sir. We have 30, 40, and 40. Yes or not? Now let's convert. Let's convert this one. Let's convert this one. Now delta to star, star to delta, both I'll teach you. This is resistance, this is resistance, this is resistance. Let's take this point as A, this point as B, this point as C. So this is RAB, this is RBC, this is RCA. If I convert, I get it as this way. I get it as this way. What is this here? What is this here? We get is RAB into RCA by product of these two. Yes, very clearly. Let's understand very clearly. Product of these two, right? Product of these two divided by total. Product of these two divided by total, right? Now, by total is what? RAB plus RBC plus RCA, right? This one is what? RAB into RBC by total. By total, let's take it as a delta total. Delta total. This one is RBC into